Hi, grade nines. Hope you're all doing well. Miss you guys. We are going to move on to unit 4.3 in our notebooklet today. And then, like I always say, super confusing because it is unit 5.3 in the textbook. So that's great. But it's adding polynomials. So if you're all caught up on the last video lessons, you can move on with us here on this one. And I'll have some textbook questions that I want you to work on at the end. You can work on those tomorrow. So today your job is just to watch the video and follow along and do these practice problems with me. So let's get started. One second here. Got a new work set up, so it takes me just a second to get used to it here. Okay, so share. There we go. So adding polynomials. So the last lesson that we did, if you are curious about where you should be at, the last lesson that we did was like or unlike terms. Now we're doing adding polynomials, and we'll be doing on Thursday. We might just do we'll do a live session again where you can ask questions. And our next unit that we'll be doing is subtracting polynomials. So today we'll be adding, and probably on Thursday in the morning, I'll post a video on subtracting. So adding polynomials is a great unit to, or a great topic to move on to right after like and unlike terms, because the concept is basically identical, okay? It's very, very similar to the like terms. Now, especially when we do it one way, we're gonna look at two ways to do it. You can do them kind of, we call it either adding them horizontally or adding them vertically, and I'll show you them both. So last section, we were combining like terms. We have to do that again for this section. So in this one, we want to learn how to add two or more polynomials together, okay? So the best way to do this is just to jump right into doing some examples, and you will very quickly see how it is very similar to combining terms, the like terms that we did in our last section. That's the first thing that we're going to do. So we have two ways to do it. We can either add horizontally or we can add vertically. Let's go horizontally first. Okay, let's go add horizontally first. All right. So what we do when we're adding horizontally, let's take a look at our problem. 7s plus 14 plus negative 6s squared plus s minus 6. The first thing that I want to do here is I want to get rid of that bracket. So let's get rid of, you know what? Let's get rid of both of the brackets. So 7s plus 14 doesn't change at all. But when we have a bracket here and we have the positive in front of it, that positive makes its way through and latches onto all of these. Now, lucky for us, there's no double negatives happening here. So everything should stay the same, but a positive and a negative will just still be a negative. So negative 6s squared, and then plus s, and then minus 6. Now, just like with our last one, our main step here is going to be grouping to group like terms. If we can group like terms, it makes our life a lot easier to see what we actually need to be adding up. So my like terms are, there's only, the s's and then the numbers. So those are the like terms that we need to add up. Maybe I'll do a double line under this one. Okay, so let's group them. So we start off with negative 6s squared. Remember, we always go with the highest exponent first. And then plus 7s plus s plus 14 minus 6. And then all we have to do is just evaluate the ones that are the like terms together. So the s's and the numbers. And that should give us our final answer, which will be negative 6s squared plus 7 plus 1 should give us plus 8s plus 14 minus 6, which 14 minus 6 gives us 8. So our answer becomes negative 6s squared plus 8s plus 8. That is how we can do it if we are adding them horizontally. Now what I want you to do is add them vertically. I'm going to show you how to add them vertically. Okay, adding them vertically. So let's rewrite what we got here. You know what? I'm not going to rewrite it. I'm going to jump right into it because I'm going to run out of room if I do. So we're going to take this first term and we're going to put it on the top of our vertical addition. So 7s plus 14. And then we're going to line up our second term here with this one. And what I mean by line up is I want to end up with my -6 here to be right underneath its like term. So that would also mean then that my plus, I'm going to write the actual 1, plus 1s would go there, and then -6s squared would go here. So now what we have is an actual vertical addition going on. You've seen this before, maybe not with polynomials. But we have definitely seen how to add things up vertically before. So a big plus symbol there. And now all you need to do is just evaluate downwards, right? You just evaluate down in the same column. So 14 minus 6 gives us positive 8. 7 plus 1 gives us positive 8. And -6s squared isn't getting added to anything. And we see very quickly here that we get the exact same answer as we did if we were adding them horizontally. So those two are the same. Okay? So that is how we add polynomials with symbols. So that's how we add polynomials symbolically. If it helps you to use the algebra tiles, you can still do that, okay? If you want to use the algebra tiles, that's fine. But I want you to start to try to get a little bit more comfortable just using the symbols as well. So question number 2, we're going to see some questions like this where you have a shape and you have to work backwards using the addition of polynomials in order to be able to solve it. So write a polynomial for the perimeter of this rectangle, simplify the polynomial after, and then you can substitute a number in for your x value to check your answer. I'll show you what I mean by that. So what it means to have these two lines here on both sides of this rectangle is that they're the same length. So if this is 3x plus 2, this is also going to be 3x plus 2. And then just having this one line here on both of these means that they are both 2x plus 1. So if I want to find the perimeter is just adding up all of the sides. So I think the best way to do this would be to use, in my opinion, would be to use vertical addition. And we would have 2x plus 1 plus 2x plus 1 plus, so that's our two sides, 3x plus 2 plus 3x plus 2. So there's our adding up of polynomials. It's that easy. We just need to make sure we're basically doing the same thing as we did horizontally. We're grouping the like terms. We're just grouping them vertically. So adding them all up like this, and we should get 1 plus 1 plus 2 plus 2 should give us 6, and 2 plus 2 plus 3 plus 3 should give us 10. So we should get 10x plus 6. 10x plus 6. So that is our perimeter. Now, B is kind of the a little bit more tedious second step we need to do here. We need to substitute to check the answer. So what I'm going to do to substitute is I'm going to just say, okay, let this x is technically representing some number, right? It can be any number. Let's say let x equal 1. That's going to be our easiest way to do it. If I let x equal 1, now I can actually plug in 1 and see if it gives me the right answer. So what I'm going to do is I'm going to write this out as a horizontal. I'm going to write out the full addition sentence, we call it with quotes, okay? The full addition sentence, meaning I'm going to use the left side and the right side are both going to be in here. So I'm going to have 2x plus 1 plus 2x plus 1 plus 3x plus 2 plus 3x plus 2 equals 10x plus 6. So now what you do is you plug x equals 1 in for every single x that you see in there, and you make sure that they're still equal to each other. Now, because I chose 1, it makes our life a lot easier because 2 times 1 is just 2, right? 2 times 1 is just 2. 3 times 1 is just 3. 3 times 1 is just 3. 10 times 1 is just 10. So I should have 2 plus 1 plus 2 plus 1 plus 3 plus 2 plus 3 plus 2 equals, and you know what? I should have shown you this here. That's my bad. Just I had a little 1, right? I plugged in a 1 for the x. But the reason I didn't write them is because it's just times 1 is just the same value. So we just got to make sure that these are all equal to each other now. 2 plus 1 is 3, plus 2 is 5, and then 6, 9, 11, 14, 16. If I add all these together, I get, oops, not the right symbol. If I add all those together, I get 16 equals 10 times 1, it's just 10, plus 6, 16. So this is just a technique to be able to check our work to make sure that we've done it right using substitution. Okay, so there you have it. Example number 2, determine a polynomial for the perimeter of a rectangle. You're going to have some examples like this in your textbook questions I want you to do. We have got one question left, adding polynomials in 2 variables. So if we have 2 variables now, how do we add these all up? Now for this case, my recommendation would be to use horizontal addition. Okay, so use the horizontal. That's my recommendation because it gets a little bit confusing when you try to use the vertical when you have 2 variables. It gets just a little bit confusing as to where to place them all. Whereas if we use horizontal, we're just going to have them all out there kind of in a mess, and we'll just group the like terms like we always do and add them up. So our first step is to remove the brackets. Now, again, no negatives out front, so there's going to be no double negatives. Just remember that the negatives are going to stick around if they're already there. So this becomes 2a squared plus a minus 3b minus 7ab plus 3b squared, and then minus 4b squared plus 3ab plus 6b minus 5a plus 5a squared. So holy smokes, that is a long one that we need to put all together. Let's group all of the like terms for our next step here. So I'm gonna just put lines underneath them as I pull them out of this top one. I'm gonna start with a squared, then I'm gonna move to a, then I'm gonna move to b, then I'm gonna move to ab, and then I'm gonna move to b squared. That's just the way that I have it written down here. It doesn't really matter how you group them. Generally, you want to start with having your higher exponents first. So 2a squared and 5a squared, I'm going to pull out here and put them together right beside each other. So 2a squared plus 5a squared. And you know what? Let's do the b squared as well. So plus 3b squared and then minus 4b squared. And then let's do the a's, where I've got a, I'm going to pull out, so plus a, and then minus 5a. And then let's do the b's, minus 3b, and plus 6b. and then the ABs, negative 7AB and plus 3AB. So using those underlines, I can just keep a more clear tab on which ones I've pulled out and which ones I haven't. Now, that way I make sure I don't forget to get rid of any of them in there or to group any of the right ones. So now we've got the A squareds together, we've got the B squareds together, we've got the A's together, the B's together, and the AB's together. So evaluate all of those individually. 2a squared plus 5a squared is 7a squared. I'll put an equal sign here because we are moving down and changing this. 3b squared minus 4b squared should give me negative 1b squared. Remember, if there's a 1, you don't have to write it, so just negative b squared. Plus 1a minus 5a, so 1 minus 5 should be negative 4a. Negative 3 plus 6 should give me positive 3b. And then negative 7ab plus 3ab should be negative 4ab. And that is all we can do with that. So that's it. That's our final answer. Put a square around it here. Just make sure you can do adding polynomials with two variables in the vertical addition technique, with the vertical addition technique, but I do think that it's more straightforward to use the horizontal. It does end up having a lot of terms all right next to each other, but what you can see is that it's easy to kind of keep track of where they're all supposed to be. So I've got some homework problems I want you to do from the textbook. Page 229, numbers 6, 8, A to D, 9, A to D, and 10A. So give those ones a shot. Email me if you have any questions about those. Otherwise, I will talk to you tomorrow. You'll have today to kind of do the lesson. Tomorrow you can work on the practice problems, and then we'll pick back up with the lessons on Thursday. Okay, see you later.